Dear students, I am going to present the anomalous properties of oxygen. Myself, Dr. Digna Varghese. Oxygen. Oxygen is the most abundant chemical element by mass in the Earth's biosphere, air, sea, and land. Joseph Priestley discovered oxygen in 1774. Naturally occurring oxygen is composed of three stable isotopes O16, O17 and O18, with O16 being the most abundant isotope. It has 99.762% natural abundance. Anomalous properties of oxygen. Oxygen differs from the rest of the members, that is sulfur, selenium, tellurium, polonium and livermorium of this group is due to its small size. We know the atomic radius of oxygen is 66 picometer. High electronegativity. The electronegativity value is high and 3.5. It is the second most electronegative element among all the elements in the periodic table. We know the first element is fluorine. It has the highest electronegative value, that is 4. Oxygen has high ionization energy, that is 1310 kJ per mole. The non-availability of d orbitals in its valence shell. We know the electronic configuration of oxygen is 1s2, 2s2, 2p4. It has no d orbitals in the valence shell. So these are the some remarkable properties of oxygen that differs from the rest of the members of this group 16. Its small size, high electronegativity, high ionization energy and the non-availability of d orbitals differs from the rest of the members of the group 16. Oxygen atom has the ability to form pi multiple bonds with itself, thus form a diatomic oxygen molecule O2. Atoms of the heavier elements of this group do not form pi bonds among themselves, as their atomic orbitals are so large and diffuse that they cannot have effective overlapping. They form puckered rings and polymeric chains, example S8, Se8, etc. So the only element, that is oxygen, shows or ability to form pi multiple bonds and forming a diatomic molecule. Other atoms in the group 16 family, that is polyatomic. Being diatomic oxygen, oxygen is a gas. Being polyatomic, the other group 16 elements are solids under normal conditions. So oxygen can form multiple bonds such as pi bonds. Oxygen is diatomic and oxygen exists in gaseous state. Oxygen does not have d orbitals in its valence shell. We know the atomic number of oxygen is 8 and its electronic configuration is 1s2, 2s2, 2p4 and it has no valence shell d orbitals. So the covalency of oxygen rarely exceeds 2. But the other elements of the group such as sulfur, selenium, tellurium, polonium, livermorium have valence shell d orbitals and hence covalency of 4 or greater than 4 can be shown by them. The effects of small size and the high electronegativity of oxygen are reflected in the properties of its compounds too. Thus, oxygen predominantly shows the negative oxidation states, mainly -2, in its compounds, except OF2, that is have the oxidation state +2, and O2F2 oxidation state of oxygen is +1, because fluorine is the most electronegative element. Being less electronegative than oxygen, the elements of sulfur, selenium and tellurium show frequent positive oxidation state in addition to negative oxidation states. So the oxidation states exhibited by oxygen is -2, -1, -half, +1 and +2. Among the group 16 hydrides forms the oxygen family elements reacts with hydrogen, water, hydrogen sulfide, hydrogen selenide, etc. And in the case of group 16 hydrides, the strong intermolecular hydrogen bonding is found in water only. This is not seen in hydrogen sulfide or hydrogen selenide or hydrogen telluride, because sulfur, selenium and tellurium are not sufficiently electronegative to make the bonds polar for the purpose. For the reason, the boiling point of water is much higher than those of the other group 16 hydrides. Water is therefore a liquid at normal temperatures, while the others are gases. In the case of water, hydrogen bond is formed. Intermolecular hydrogen bond is formed. Hydrogen bond is the bond exists between the high electronegative element and the hydrogen atom. But this bond is pure intramolecular polar covalent bond, while one of the water molecule and other water molecule, that is connected through hydrogen bond between the hydrogen of one water molecule and oxygen of the other water molecule, that form intermolecular hydrogen bonding. This occur only in the case of water. In the case of hydrogen sulfide, hydrogen selenide and hydrogen telluride, there is no such hydrogen bonding exist. So the boiling point of water is high than the other hydrides of the group 16 elements. Water is therefore exist as liquid at normal temperature, while the other like H2S, H2SC and H2TE are gases. Oxygen being the more electronegative than the rest of the group 16 members. We know the electronegativity value of oxygen is 3.5, and the formation of dinegative ion O2 minus is much easier than those of the H2 minus, Sc2 minus and Te2 minus, because it has a most electronegative element like oxygen has a tendency to attract more electrons towards the atom, but the others, the electronegativity value is decreases, so such attractive power of atom decreases. And also from top to bottom the metallic character increases. At normal temperature, oxygen is a gas which shows paramagnetism. However, the other members are solids in which puckered rings or polymeric chains exist and do not contain unpaired electrons, hence they are diamagnetic. Paramagnetism shows only if there is unpaired electron. In the case of oxygen molecule, in the molecular orbital diagram configuration or molecular orbital configuration, the oxygen is paramagnetic, there is unpaired electrons, while in the case of other elements there is no unpaired electrons and hence they are diamagnetic. Oxygen molecule is highly stable. Its bond dissociation energy is about 494.6 kJ per mole. Oxygen combines with other elements, metals or non-metals, only at higher temperatures. The reaction requires high energy of activation. This is the reason why in nature oxide ores are fewer than the sulfide ores. There are several oxygen carrying metalloproteins like hemoglobin, myoglobin, etc. present in biological systems in which oxygen is coordinated to the metal ion. Apart from this, a number of transition metal peroxo and superoxo compounds have been synthesized in which oxygen is ligated to the metal ion in this manner. In the case of bonding in superoxide compounds, and this shows the bonding in peroxo compounds. The oxygen-oxygen bond distance in superoxo compounds is about 1.25 to 1.3 angstrom, and that in peroxo compounds 1.45 to 1.50 angstrom. So, bond distance, oxygen-oxygen bond distance in superoxo compounds is shorter than peroxo compounds. So the anomalous properties of oxygens are: oxygen is gas, oxygen is a diatomic molecule, oxygen is have high electronegativity value, so it is exists as non-metallic, and most of the compounds are ionic in nature, and it has no valence shell d orbital, so it is no maximum covalency exhibits is 2. Oxygen molecule is highly stable because of its high bond dissociation energy, and oxygen carrying compounds such as metalloproteins, superoxo and peroxo compounds exist. Because of its high electronegativity value, it shows hydrogen bonding, so it's a hydrate like water molecule exists as liquid and has high boiling point. Oxygen molecule is paramagnetic in nature. This is all about the anomalous properties of oxygen. Thank you for your attention.